Water quality in rivers. Water quality is sensitive to changes in landscape patterns, mainly during urbanization. Different tools and methods are used to compare landscape patterns. These tools define the transformation rules of landscape influences as well as evaluate the connection between the changes of landscape patterns and water quality in rivers. Tools and analyzing methods. Geographic Information System, also known as GIS, water quality indicators, and conductivity tests. A geographic information system is a system intended to manage, store, manipulate, analyze, capture, and demonstrate spatial or geographic information. GIS applications are tools that permit users to generate interactive queries, evaluate spatial information, and revise data in pod maps, and present the outcomes of all of these operations. The proper spatial scale should be selected when analyzing the relationship between landscape pattern and river water quality. Water quality indicators. Water quality index is used to calculate the quality conditions in rivers by observing water quality indicators. These indicators are dissolved oxygen tests. This measures the amount of oxygen dissolved in the water. Oxygen is essential for both plants and animals, but high levels in water can be harmful to fish and other aquatic organisms. Water temperature. Aquatic organisms are dependent on certain temperature ranges for optimal health. Temperature affects many other parameters in water. A pH test measures the alkalinity or acidity of water. A pH of 7 is neutral, below 7 is acidic, and above 7 is basic or alkaline. Acid rain from auto exhaust or other pollutants cause a drop in the pH. Pollution from accidental spills, agricultural runoff, and sewer outgrowths can also change the pH. And E. coli, also known as fecal coliform bacterium, that comes from the human and animal waste. The Environmental Protection Agency uses E. coli measurements to determine whether fresh water is safe for recreation. Specific conductance tests measure the ability of water to pass an electrical current. Nitrogen is a nutrient that is essential for growth of all living organisms. Excessive amounts of nitrates increase algae growth. Algae can rob the water of dissolved oxygen and eventually kill fish and other aquatic life. Transparency measures how far light can penetrate a body of water. Sunlight provides the energy for photosynthesis and determines the depth at which algae and other plants can grow, defining the ecological makeup of a water body. Visual tests. Physical observations of water. Water clarity is recorded, plants, and other aquatic life, as well as recording the amount of rainfall received in the area. Conductivity testing. Conductivity is a measure of the ability of water to pass an electrical current. How well a solution conducts electricity is determined by a number of factors: concentration, mobility of ions, valence of ions, and temperature. All substances possess some degree of conductivity. In aqueous solutions, the level of ionic strength varies from the low conductivity of ultra-pure water to the high conductivity of concentrated chemical samples. Importance of conductivity. The significance of conductivity in water. Micromoles are the basic measurement for conductivity for liquids. The conductivity range for distilled water is 0.5 to 3 micromoles per centimeter. U.S. rivers conductivity range from 50 to 7,500 micromoles per centimeter, and industrial waters can go from 10,000 micromoles per centimeter. When it comes to bodies of water, conductivity measures the quality of the water, as well as pollution levels. The conductivity of distilled water is low, which is why they consider it an insulator. If there were minerals and metals suspended in distilled water, ions would form, which would be measured as conductivity. A conductivity meter measures the amount of electrical current or conductance in a solution. Conductivity is useful in determining the overall health of a natural water body. It is also a way to measure changes in wastewater procedures at water treatment plants. Conductivity meters are common in any water treatment or monitoring situation, as well as in environmental laboratories. How conductivity is measured. Conductivity is measured by adding an interchanging electrical current to two electrodes that are engrossed in a solution and calculating the consequential voltage. Throughout this process, the cations travel to the negative electrode, the anions to the positive electrode, and the solution behaves as an electrical conductor. Conductivity can be measured using a conductivity meter. Consequences. The consequences of changes in landscape patterns can have a major impact on the decline of the quality of river water. Polluted rivers don't only impede imbalances in ecosystems and rivers, but also threatens the health of the community and economic sustainability. To guard rivers from pollution and prevent other issues due to this, more scientific clarification is needed in regard to the impact land use per cover has on water quality. What needs to be done? Using proper metrics in accordance with water measures. Using the proper landscape metrics that are related to urban land use are particularly useful when used together with water quality measurements. Continue the monitoring of rivers for pollutants. Urbanization must be reduced in and around the rivers. River monitoring and restoration must consider land use and land cover patterns on multiple scales, ranging from buffer zones, catchments, sub-watersheds, as well as entire watersheds. Natural and social scientists must work together in order to fully understand and successfully restore degraded river systems in this region.